I can tell you some statistic, okay, some history. Last 2 years, how many quiz do we have? Anyone know? How do you know that? How do you know how many quiz happened last 2 years? You go to my website, download the old quiz. How many quiz is there? Quite a lot. Okay. So last 2 semesters, I think you have quiz about every time. But I cannot give you quiz every time for this year because there are some rules saying that if any of you request 20% more or 50% more time, the quiz must not be regular and the quiz time must not exceed 20 minutes. So I do 10 minutes. Oh, sign up sheet, right? You're a good student. Everyone comes, so you should get good score. Don't worry about it too much, okay? But do better next time. Anyone get the derivation done?
Yes. That derivation
Did you submit it, Maya?
Oh, no,
I see that you for your. Did you submit it? Where's your? You will get 5, okay? Let me give you an exam paper. Where's that? Is it here? Okay, alright. Have some okay? You have a picture, it's fine. If you write something, you get something already. Don't worry about it too much, and at the end you get the scale point. Okay? So, you ready for the lecture? Okay. So, by now, I think you should appreciate this equation and about to know how to do derivation of this one, right? You may see that, okay, I missed one of that term, I get stuck somewhere or something. But next time, or next week, I know for sure that within 10 minutes, you can do this, right? Probably. So next Monday or next Wednesday, what?
We know it better when we have actual homework and we're using it.
Oh, you know better when you do the quiz and you do the quiz second time. Don't worry about this time. This time in particular, you get a scale. How many people do you think they get 10? I don't think any one of you get 10. Probably highest score is 6, 5, 5, 5 or something. And you get +5, so don't worry about it. If you get 4, so it should be fine. Alright, I hope you appreciate this equation, and next week, this time, I think you will know how to do combined momentum equation. It is important to the point where you should memorize it, okay? Last time we said that this equation is the implicit form for HL tilde or capital or small h. The reason that I said that is as follows. Okay, take a look at D. You see this small d. Akin, where do we use that small d? D sub L. Where do you think? In the Reynolds number calculation, yes. Okay, in the Reynolds number calculation. You see that? So D sub L used in Reynolds number calculation for liquid phase. D sub G also used in Reynolds number calculation for gas phase. Okay, this D we define as 4 multiplied by area divided by weighted wall perimeter. Okay, 4A over L or 4A over S. So for liquid, area is area that occupied by liquid. That area, right? Oh, okay. The area at the bottom, that's AL. What about length? I have it SL. You notice that length is the length that generate shear stress or have friction. For liquid flow, we assume that friction happens from the bottom part. Friction due to the interface is negligible. Okay, if we assume that friction from the interface is negligible, then we don't include that length. Okay, so you will have 4AL over SL, just that. So if shear from the interface is included, for example, for gas phase, gas move faster than liquid. That is our assumption, right? So liquid drag gas back. When liquid drag gas back, then we have SI. So length around gas phase is this length plus that length. Okay, so when we calculate diameter for gas phase, hydraulic diameter for gas phase, we use 4 multiplied by AG divided by this length, because all of those lengths generate friction. Okay? Yes, Raymond?
You said it's negligible, then why do you have a shear term for
Why do we have shear tail? Why do we neglect it somewhere? Why do we don't neglect it somewhere? So for liquid phase, if we have it, this part, right? You see this part? That is the part that we think it generates friction. This is, realize that neglect or not neglect is not the actual shear that we neglect. We neglect it for the purpose of Reynolds number calculation. In single phase flow, when we have Reynolds number calculation, what do? We do 4 multiplied by whole area divided by all this perimeter, right? So which is 4 multiplied by pi d square over 4, and whole pi perimeter is pi d, right? So this is equal to diameter. So hydraulic diameter for single phase flow is diameter, 1 diameter. For hydraulic diameter for Reynolds number calculation, we want to use the same definition, area divided by perimeter. So what is the perimeter that velocity is 0? So in the single phase flow case, we use whole length because all those length velocity it is 0 at the edge, right? For this case, it is 0 over here, but in the middle, it's not quite 0. Okay, but for gas phase, in the middle, gas may see this interface as 0 with respect to gas velocity because it moves a lot slower. So we may say, okay, this part is very slow and gas velocity at the interface is quite slow, so we do some kind of approximation. Whatever we do, Reynolds number is just rho v multiplied by characteristic length. Characteristic length, we want it to be as close as the theory that we have. The theory is the length that velocity is 0. For gas, if we neglect the middle one, but the middle part, or we add the middle part give us closer to the definition of Reynolds number. So whatever we do, it is a good approximation, it's not exact. We don't actually neglect tau, okay? This is the variable for Reynolds number calculation. So diameter is depend on 4AL over SL. Hydraulic diameter of gas phase is 4AG divided by SG plus SI. So we calculate actual Reynolds number from actual velocity. You see that? That is the actual velocity. Actual velocity is volumetric flow rate divided by the actual cross-section area occupied by liquid, right? So gas velocity, this term is gas volumetric flow rate divided by actual area occupied by gas. So if the actual Reynolds number is more than 2100, we use Blasius type friction factor, where constant is 0.046. Friction factor, we can write it as C multiplied by Reynolds number raised to the power of minus something. If it is turbulent flow, C is 0.046 and N is 0.2, right? If it is laminar, C is 16 and N is 1. So this is a friction factor. Okay. Question? No more question? When is the next time that what time to and you cannot tell. Anyone haven't submitted homework yet? You all submitted homework? By mistake, I put the deadline to be 11 p.m., but it should be a.m. Okay.